Welcome, everyone. I expect to hear welcome. Thank you, or whatever. All right. Extra penalty for those who still are on TikTok or Instagram or whatever. My name is Himanshu Gupta. I'm the CEO and co-founder of ClimateAI and a former policymaker in climate from Global South. But most importantly, I also belong to an AI household. You know what that means? So my wife also runs an AI company in San Francisco. And this is how our discussions go in the house. So as an example, when I'm working and I'm not listening to her, she goes by like, why are you not paying attention to what I'm saying? And my reaction is, my transformer model is not as good as yours. For those who understand, the joke. And then when I tell her like, hey, you didn't do the dishes this day, and then her reaction would be, your transformer model is hallucinating. All right, so with that context, we have an exciting panel and panelist in front of us representing various fields and diverse industries. And I'll ask them to introduce themselves. And I gave them a prompt that introduce yourself as you are writing 2 tweets about yourself and not a LinkedIn post. So this is their challenge. I'll start with you, Andreas.
So my name is Andreas Berger. I'm the CEO of Swiss Re Corporate Solutions, which is the corporate and prime insurance arm of the Swiss Re Group. I embrace and I have the northern and the southern hemisphere in my soul, in my heart. So I was born in Rwanda, grew up in Africa and Rwanda, and in the northern hemisphere in Portugal and Germany. So I'm inclusive by nature. And I know AI, there's a lot of discussion around conclusion. So that's something that we maybe should discuss today. We should also discuss use cases. What does AI really mean in a business context? So I'm the one representing maybe the managerial side today, accompanied by all the tech expertise that we have around here. So that's all I have to say. Thanks.
Great. Hi, I'm Tom McDonald. I'm the Chief Scientific Officer of Orbital Materials. So I'm the CSO of an AI company. I'm actually a chemist by training. So my focus has been developing carbon capture and carbon removal technologies for the past 15 years. First as a spin-out from my own PhD at UC Berkeley to a company that was acquired a few years ago. So I joined Orbital Materials last year, a London-based company focused on getting technologies out of the laboratory, but accelerating them with artificial intelligence. So what we're focusing on is how can we, the point I heard earlier was outcomes, not algorithms. Use AI to accelerate the developments to help realize some of the cost reductions that are ultimately going to be required to make a sustainable world, and use AI to do so. So it's great to be here today.
Hello, everyone. My name is Isa. I am the ExCo member at Swisscom looking after strategy and business development. Inclusion is also part of my heart. If you can't guess why, have a look at the panel. My 2 tweets, what I'd like to talk about is around how AI is helping us as Swisscom achieve our sustainability targets on one hand, and how we as an investor feel that we need to help drive an ecosystem that really drives some of that bottom-up development around sustainability as well. You got your own.
Thank you. My name's Thomas Vellacott. I'm CEO of WWF Switzerland. WWF, that's the Nature Conservation Organization, not the wrestlers. I'm here representing lots of different kinds of intelligence, not artificial, but very natural, in terms of the intelligence we have out there in nature with different species. But I'm also very excited about artificial intelligence because, we're obviously facing 2 very grave and interrelated crises with climate change and biodiversity loss. But at the same time, we're in the midst of a massive and deep-rooted transformation of our economies to net zero and nature positive. And the question is, are we fast enough? And I'm convinced that AI is one of these technologies. There's not one wonder technology, but one of the technologies that can help us speed up this transformation, and we dearly need it. Thank you.
Hello, everybody. My name is Remco van Erp. I'm the co-founder and the CEO of a company called Corintis. We're a startup from Switzerland, so we're on the home turf here. What we do is we're working on what's really behind all of the AI models today, which is the chips. So we're looking at how can we advance our global compute capacity, how can we make chips better, and how can we make chips more efficient. And what we in particularly look at is, as chips get more powerful, they get very hot, how can we make AI cooler? That's what we do.
Well, thank you all for all of your tweety introductions. And let me just start with talking about the light bulb moment of the light bulb. Can anyone guess what is this light bulb doing in this AI panel about sustainability? And whoever guesses it will get this light bulb. I'm not cheap. This is like Alexa-enabled light bulb.
Energy.
Close. Anyone else? Okay, this is, sorry? Sort of. If you were listening to the introductions of some of our panelists.
Sustainability.
All right, I think I need to take the... So it goes back to the history. And I'm talking about Edison and his team. Oh, yes, sir.
He had like 1,000 tries till he made the bam idea and it flew. And maybe this panel is like a bam moment. You know, this moment when you click and it gets light. And that's the idea behind it.
No pressure.
Well, you know, I would have given you the light bulb, but you required a hint, right? But close. Close. I mean, the point being, Edison and his team took 3 years and 3,000 trials to invent the light bulb. And the reason being because he kept on, or they kept on, experimenting with multiple materials which could act as a filament for this light bulb. So they wanted to figure out materials which can withstand high temperatures and yet are affordable for this to become a success. And they eventually landed at a carbonized bamboo material. This was the light bulb of the 1910s and 1912s, right? So I call that the light bulb of the light bulb moment. Light bulb moment of the light bulb, right? And the reason it's relevant for us, as some of the panelists introduced themselves, is what we'll see is how AI is acting as a time and effectiveness multiplier to solutions of climate change. Now, if Edison and his team had this light, had the same access to the AI solutions our panelists are talking about, it would have taken like less than 2 weeks or 3 weeks to invent a light bulb, right? So with this, when we talk about, as I said, the common theme among all the panelists was the solutions. AI can actually help us accelerate solutions to climate change and make them more effective. So we'll see that, and we'll discuss that under 3 lenses. One is the adaptation lens, the mitigation lens of climate change, as well as the risk that AI in sustainability solutions also poses. Now, with such an informed audience who could guess this riddle, I don't need to tell you why we need an accelerated solutions to climate change, right? Because we have finite carbon budget, we have finite water budget, we have finite soil budget. And we are running out of years to act on it. As simple as that. So let me start with talking about how AI can help us reducing basically the amount of carbon dioxide we pump into the atmosphere and how much water we consume in our daily lives, or how much damage we are doing to soil every day, right? So let me start with you, Andreas. Would you want to talk about what you are doing from a Swiss Re standpoint?
So, first of all, our purpose is about we make the world more resilient. So it's almost built into our purpose. So what we do is actually deal with data and with risk. And all we have is data and people. So by definition, data and data insights is basically what we do and what the value creates in our business. So we do risk modeling. We use data and model risk. And we use enhanced data, not only historical data. So we looked at data and at climate change for quite some time. And already actually in the 70s, we came up actually with the warnings because we saw it in data, in historical data. But now when AI kicks in, that will enrich actually the historical models that we have. So what we do now is we bring the information, the science-based information from IPCC, for instance, and we bring it together with our data on hazards, floods, wildfires, storms, etc. And then bringing it together and bring risk insights back to the communities, to other insurance companies, to corporates, to communities, municipalities, governments, etc. And this will create the awareness of what their actions, what the impact of their actions actually are in related to society, to environment, etc. That's where it starts. It starts with the awareness. And we can talk about it a bit later, that most problems are circling around lack of awareness and lack of quantification of the exposures that there are in the world. We understand by now exposures because we're confronted, but we don't know exactly how to grab it, how to quantify it, and what to do about it. That's the blind spot, and that's where we come in.
So basically, like, can we understand the impacts of our daily actions, the way we understand the impacts of food we eat for our health? Translate that to the planetary health. Basically, like, if we eat burgers, we know what it will do to our tummies, right? Or cholesterol or whatnot. So we started with adaptation. That's great. Isa, you wanted to talk about some of the tools you're deploying within Swisscom that can help with adaptation.
Yeah, and I think it's important because if you think about, especially generative AI, we think a lot about the kind of power consumption that takes to run some of these models. As an infrastructure provider, like we are, the big challenge that we're facing is how do we keep an infrastructure that's super reliable, that's got the redundancy to deal with peak exposure and stuff like that, but do that with ever decreasing impact on electricity and on energy consumption. And that's where AI, not necessarily generative AI, but machine learning has helped us get better every year and will continue to help us to get to net zero, which is a goal we have and are pursuing very strongly, right? And that's about things like how we put our towers to sleep when they're not in production. How do we change over from one tower to the next if a tower's down, right? All of these things that will enable the consumer to have a seamless experience, but allows us to have less redundancy in the system, all of which requires a whole load of energy.
Yeah. Infrastructure is a big puzzle in the solutions for climate change. While we are on data centers, let me go to you, Remco. Can you talk about what your startup does and how are you thinking about improving the efficiency of data centers?
Sure, yeah, and I think we're very aligned with Isa here. I mean, if you want to deploy these new models and compute globally in an efficient way, it really starts with making sure it consumes the least amount of power and doing it very energy efficiently. And I think if you, for some numbers in context, like the global data center industry consumes around 300 terawatt hours on an annual basis. That's as much as the UK as a country. So if you would put like the internet on the map, you talk about the UK. And surprisingly, even though the internet traffic has increased by around 20-fold over the last decade or so, the energy consumption has remained pretty much flat, which is really due to improvements in efficiency. And infrastructure plays a big role. Chips play a big role because every year, every generation of chip becomes around 40% more efficient than the previous. And these are compounding gains that we first made possible with clever algorithms. I mean, the first chips, if you go 60-something year back in time, were drawn by hand, like a few thousands of transistors. And then this became millions of transistors. We used computers to design computers. And now we're at a point where chips are so complex, where there's a lot of AI being used in the chip design process to start with in order to make sure we can keep battling the increasing traffic with the increase in efficiency that's required in order to get there. So I think making chips more efficient, and as Isa mentioned, handling the inefficiencies that comes out of chips, which is heat, in a better way. Because in the end, what causes water consumption is the cooling in data centers. And what causes a big impact on the energy consumption too is the cooling. And that's something that we as Corintis do. We look at that second part. If we know that every generation of chip is going to consume more power than the previous, and it's going to get hotter, how do we make sure that this heat can be handled in a sustainable way? And that's, I think, compounding all those efficiency increases together. AI plays a huge role in there in order to make the future of AI more sustainable, which means we go full circle.
While we are on the subject of future of AI, and let me stay with you here, Remco, on making chips more efficient, right? What do you think would take for us to say that the giants of the chip making industry, right, NVIDIAs of the world and AMDs of the world, what will it take for you to sort of, or them, to adopt your technologies in the next 4 or 5 years? Because if they can do so, we are looking at 80 to 90% reduction right away, right? Caveat, I hold shares in both NVIDIA and AMD.
No, I think what it takes is urgency. I mean, if you look at, for example, I take the increase in power in chips as an example. If you go about 10 years back in time, a GPU, like the chips that we use for training machine learning models, would consume around 150, maybe 200 watts if you really get something top of the line. And now we're looking at 1,000 watts. And you know, this is really a trend that goes really rapidly. And the moment there's no other solution left, the moment you hit a wall, I mean, a lot of people are willing to make a move because it becomes an urgency. And I think secondly, a really interesting trend that we see now is that, I mean, when we talk about chips, we talk about NVIDIA, Intel, the usual suspects when it comes to chip design. But the very big hyperscalers, I mean, for example, Google, Microsoft, Amazon, they're designing their own chips right now. They're designing their own systems and infrastructure around those chips. They pay their own electricity bill, and they are scrutinized for their emissions. And I think that very holistic view on A to Z is also a big driver in making this, accelerating this adoption and new technologies.
Yeah. Again, staying on this topic, question for both of you, Andreas and Isa, right? You are buying, I think, Googles of the world and Intels of the world are probably your vendors, right, in the data centers that you use. What will it take for you to sort of mandate, right? If you are supplying us this chip or that chip, looking at your scope 3 emissions, you'll only get a contract if the chips satisfy this criteria or that criteria.
Look, we already do a fair bit of that, right? Because, again, right, we pride ourselves in having some of the most efficient data centers in the world, and you don't get there if you don't work with your partners, right? And so, on one hand, you know, investing in some of those technologies to actually get them up and running, but on the other hand, absolutely, right? I mean, it's an ongoing collaboration with your partners and letting them know that we deeply care about sustainability and our carbon footprint is the only way it's going to change things. And not only do we care about, our customers care about that too, right? So, absolutely.
Let me give you an example how we dealt with the awareness that our consumption matters. And let's take the cloud example. There was a hype everywhere. Everybody needs to be on the cloud. And companies, how did they react? So you had to basically incentivize people to move to the cloud as quickly as possible and basically use all applications and move them over to the cloud. Because there might be resistance in companies, etc. So you incentivize people for this behavior. What companies then didn't realize was that all applications were probably not relevant. And they haven't thought about the consumption, cloud consumption. And it went through the roof. And only then those big tech firms came up with the idea to introduce cloud economics. By the way, another way of making money with consultants. So you went back to the company and said, look, how would you do it today? You would basically clean up first your applications, say, okay, what are really the relevant ones? Which one do you have to shut down anyway? So then a third maybe would go to the cloud, and then you start to measure consumption. That's the first step. We can talk about all fancy stuff. That's the first step. We learned, we're much better, and when it comes to AI, we adopt exactly this thinking.
Can I just add a quick point, right? Like, and to your point there, I think it's essential. It's not easy, but it's essential that all companies track Scope 3, because that's the only way. You cannot move stuff, you know, the kind of nasties off your own premise and be done with it, right? So, and that's something, I know that's not easy. We struggle with some of our partners to try and get there, but it's absolutely essential.
That's very encouraging to know. And so let's shift gears a bit. The few examples we sort of heard were about effectiveness of climate solutions, effectiveness of cooling solutions, and so on and so forth, or effectiveness of climate modeling. Let's switch gears to acceleration of climate solutions, right? And how can AI help us find new solutions faster and cheaper? So let me start with you, Tom. So tell us a couple of use cases where you've been able to create value on the ground with your AI models.
Well, I think your example of Edison was really apt, because 100 years later, most technologies are still developed the same trial and error way, where if it takes 3 years, when you think about that, ultimately our goal at Orbital is to develop a foundational model that allows us to use those types of predictions to accelerate the development of the clean energy technologies that I think the world is really counting on to ultimately meet our net zero and other sustainability commitments. You know, we're assuming fairly massive reductions in the cost of a lot of technologies while also achieving significant scale. And so we need to find and quickly develop what are the most effective technologies for any given area. So, you know, when we looked at what our business model was going to be, you know, one, I think, traditional model of using something like artificial intelligence would be to develop a list of solutions and try and go and give it to someone else and say, here, you should go and do this instead. But we realized that there would be really too much risk in doing something like that. It still requires some level of acceleration, but also trial and error. So that's why what we're actually doing is not only building a foundational model, we're also building a laboratory. We're trying to take on that risk ourselves to demonstrate that we can make better materials that have the performance, the stability, the low cost, really that are required to ultimately develop things like better carbon capture materials. If you look at something like what Climeworks is doing direct air capture, the cost of the material, the performance of the material, the lifetime of the material, those are really critical factors in ultimately determining what is the final cost of doing something like carbon removal, which is really a critical technology in abating really any source that we can't directly electrify over the coming years. Finding better ways of getting the most efficient materials, efficient processes that use energy smartly, that integrate well with other sources of waste energy are really critical paths to, I think, achieving the cost reductions that the world is counting on. And we personally believe that AI will really be an accelerant in doing and developing those types of technologies.
Great. So while we are on you, Tom, a couple of questions from a founder standpoint, right? So for some aspiring entrepreneurs in the audience, or maybe I can see some entrepreneur faces which I know already. How do you come to a particular use case? This is the use case you're going to start working on the first time, right? So what was the thought process of deciding this is the use case your startup is going to start with?
Great question. So going a little bit more back into my background. So I actually created, as an entrepreneur, a company based upon my PhD work. And so I think one of the reasons what Orbital Materials was doing resonated so much with me was that between my PhD and my time at Mosaic Materials, that was ultimately 13 years to develop that technology. And so I experienced firsthand on why we need accelerants for doing something like this. So I joined Orbital not as a founder, but as chief scientific officer about 6 months ago. And I think that was one of the reasons it really resonated so much for me. But great question. How do we ultimately find product market fit? So I think what we were looking at was across a range of materials technology, what really is an area in which we need significant cost reductions, for which we believe we can develop a clear competitive advantage given existing technologies and solutions out there, and that ultimately have the potential to deliver venture scale returns over a long timeline. And so what you look at for something like carbon removal is a market that has really a very expensive early set of customer base to really try and build a technology. But what everyone wants for those early purchases to be is to be an accelerant for the overall field, so we can rapidly reduce costs and allow carbon capture and carbon removal to be a generalized approach for quickly mitigating technology across a range of industries. And so when you look at the scope of the potential market that you're going to see over the coming years, I'm a firm believer that there will be gigatons worth of demand, and there continues to be gigatons worth of demand, but that demand is predicated upon the idea of delivering significant cost reductions. And so it's an area in which you can clearly define value if you can make new materials and process technologies early enough to get them on the path to scale quickly.
Great. We'll come back to this point, but let me go to Thomas Yu. So tell us a bit more about, with your position within WWF, right? What are the use cases? And you provide an interesting perspective from a nonprofit, right? Where the development of AI is not just about optimizing returns. In your case, it's also about optimizing returns, social returns or nature returns, and so on and so forth. So tell us, like, how is WWF thinking about this, and then what are the couple of use cases you are focusing on?
Yes, it's about optimizing impact and speeding up impact. And I'll give you a couple of concrete examples. We are working on two large areas of work. One is working in the field with local communities to protect nature. And the second is working with companies and regulators to speed up the transition. And I'll give you one or two examples for each. So if we go out into nature, first of all, you can only protect nature if you know where it is and what's actually out there. And we've made huge strides there in the last couple of years in terms of observing, remote sensing data. There's so much more around, whether it's satellite, whether it's drone, whether it's listening into a forest, based on the soundscape you hear back, being able to then say what species actually live there and what's missing in the soundscape. So there's all this huge amount of data. But if you've ever tried to find a picture on your iPhone or your smartphone, in your thousands of pictures, you know how time-consuming it is. So imagine the camera traps out there taking thousands and thousands and millions of pictures, and then some poor research assistant having to go through those pictures to identify, out of the 1,000, the 3 that have a jaguar on them. And now imagine if you can start using pattern recognition and machine learning to speed that up. And that's exactly what's already happened. We co-developed a platform where you can upload your camera trap data. More than 30 million pictures have already been analyzed. And that's an open platform. That's not WWF. We've done that with a number of different organizations together, because together we can speed this up even more. So that's a very concrete way of knowing where nature is, that you can go out and protect it. But let's take that one notch further. Can you then bring in AI to actually make it predictive? And one huge area we are up against is deforestation. And imagine if you weren't just chasing deforestation where it's happening, but if you could actually anticipate where it's likely to happen. And that's exactly what we did in another application. We developed something called Forest Foresight. And what it does is it just analyzes geographical data. It looks for certain patterns. For example, if you have a new road emerging, that's a warning sign. There's likely to be deforestation there. If you then look at what species the loggers are looking for, and you overlay that, you can actually identify the area where it's most likely to have deforestation in the future. You can then tell your local authorities about that, and they can go and check on that. So you can actually start to do something about it rather than just finding out where it is. So that's kind of on the nature side of things. If we now look at the company side of things, and how can we help companies speed up the transition to net zero and nature positive? One application we developed together with the University of Zurich and the University of Oxford is an AI application that analyzes transition plans. So you have all those companies out there now coming out with their net zero commitments. That's a great thing. We love that. but then they need to come up with a plan for how do they get from A to B in terms of what does their transition look like. And that's where it sort of starts getting a bit, well, let's just say there's a big range of quality in terms of those transition plans. But it's very hard to analyze those transition plans to find out which ones are the credible ones and which ones are not. But it turns out you can actually look for certain patterns there again and start identifying the ones that are more likely to be credible versus the ones that look kind of greenwashy. And that's something we're doing also in collaboration with regulators to help regulators, financial regulators, figure out where are the ones they need to look at carefully, because there may be systemic financial risk based on companies not identifying the risks they face with regard to climate change and biodiversity. So by helping investors and by helping regulators identifying the greenwash or the likely greenwashers out there, and then being able to deep dive into it and check it out, we can actually make sure that this transition happens in a credible and therefore in a more rapid way. So that's just a couple of examples.
Great. I really like both the carrot and the stick approach there, working with the companies as well as working with regulators and putting pressure on companies. So I just want to go deeper there, right? We have two of the largest corporates in this panel, right? What would it take for WWF to take this solution, either on like biodiversity monitoring in forest or deforestation monitoring, and put this in the workflows of Andreas and Isa here? And can you talk about like what has been your experience in corporate partnerships for such solutions?
So we see companies as, not the problem we need to point to, but as part of we're all part of the problem, but also as part of the solution in order to get there. So we work very intensively with companies. We've got a long history of corporate partnerships. And I'll give you one or two examples there as well, maybe. One is we identified a tool which we launched last year at the World Economic Forum called a biodiversity risk suite, where we look at where do companies have biodiversity risks in their supply chains. Because biodiversity is a couple of years behind climate in terms of companies being aware of it. Well, companies are quite aware of it, but they don't know how to go about it, to do something about it. And we said, well, how can we actually help develop a solution like this biodiversity risk filter, which they can upload the data of where their suppliers are in order to identify what the biodiversity risks are in their supply chain. So that's a very concrete thing we developed. It's a free application which is on the internet if anyone's interested. And then we go deeper in partnerships. We co-developed something called the Science-Based Targets Initiative together with other NGOs and the United Nations to have a credible standard for companies to make commitments. And then we go deeper with companies that say, well, let's actually collaborate on how we do it. And I'll maybe give you one example there. We work with SIG, with the packaging company. They've made a commitment that they will protect and restore forests in 650,000 hectares worldwide. So we work with them in terms of how can they do that very, very concretely. And I think that's what we're looking for, because at the end of the day, it's only by working together that we are going to achieve the speed which we really need in this transition.
I would love to have reactions from both of you. And please give your honest reactions. Not the sustainability report forward reactions. I'm looking for honest reactions.
Look, for us, honestly, it really is a matter we care deeply about, and which is why we have embraced science-based target, right? Which is the most, at this point, probably the most objective, I don't know if you will, right, way of trying to measure what you do. Now, having said all that, right, I think this is an emerging field, and you've got to re-challenge yourself on a regular basis, right? And for example, it's one of the things that we are thinking about, because we currently don't have a specific target around biodiversity support and whether we need to embrace that more, right? I genuinely feel if you want to embrace diversity as a company, you need to allow others in, you need to challenge yourself, with different approaches to this, right? I mean, a few years ago, we all thought that carbon offsets was like the way to go, and we're going to rescue the planet that way, and that was well intended, but probably not the whole answer, let's be honest, right? And so how do you keep getting smarter together? Because this is our joint problem.
Andreas?
Let me add a bit of a reality check and be a bit sober. It all looks and sounds very, very good. But if I remember last year at the WEF, a lot of CEOs went out and made commitments. And the year before, by the way, too. So everybody was fired up. Everybody was energized, engaged. We had so many new jobs being called Chief Sustainability Officer, etc. They probably engaged with you, Thomas. And so the challenge is that this is a new job in a large corporate organization. It's another silo, doesn't have access to the data that sits somewhere in the organization, and people don't know where the data sits. They don't even know which data is needed. So you have a single problem that you address, and we said it's not good enough. And I was attending a WCSD dinner, World Business Council on Sustainable Development, on Sunday evening. The first thing one of the CEOs said was, I'm new in the job, and guess what? How many additional commitments did I make? 0. Because he knows I can't fulfill it. So that's where we kicked in. So we said, the problem is not the technology, the problem is not the great ideas we have and the willingness. So you might have more willingness actually than ever before. The problem is actually to identify the relevant operational data that sits within the organization that you deal with as a company, to make this available and then start to overlay everything we have. And we said we should go a step further. So what we did was to create a platform and to tell people we will help you take control of your risk and of your sustainability actions. Take control, because everybody was always relying on someone else, usually external consultants, etc. So first of all, you have to accept data is dispersed everywhere, unstructured, difficult to access, so you can't make sense of it. So we said, bring the data on a platform. You get a secure private subtenant, bring it on the platform, whatever the structure is, invite your colleagues from all divisions, including the new sustainability officer, because suddenly the officer will get access to data that they never thought of. In the moment that the data sits on the platform, it's going to be mapped with our data model. So it gets a shape, and we create a digital twin of their reality, a representation of their reality. So for the first time, they have now data sitting in one spot, having a single version of truth, a shape, and now you can define what's the event that I'm going to use to stress test this digital twin. And now we can talk about biodiversity, we can talk about all NatCat, natural catastrophe events, we can talk about pandemic, etc. How does your digital twin behave? And it then feeds back actionable insights. That's where we then kick in. It's not insurance or whatever, it's increasing your own resilience. But you need to upgrade and upskill your people to understand, how do I deal with data and data models? Big problem. Everybody's talking about digitization. Big problem. You have to collaborate within companies, overcome the silos. Huge problem in corporates. And then you need to actually have very clear focus targets. So this platform then invites also third-party data providers, like in an app store. So WWF can actually be a third-party data provider. So once you have your data in one spot, access your data and then use it for your own modeling and understanding what my current situation looks like, and you can project into the future and then take actionable decisions and so on.
And I second your reasoning there about, and I really like the point about upskilling your employees. I can testify to it. We have worked with more than 60 of the Fortune 1000 corporates out there. If we come to think of it, the corporates who have been able to scale and adopt our solutions, AI solutions, versus those who have not been able to scale, in spite of, you'll see the CEOs being very proactive and wanting to do that, like as soon as possible. The single biggest reason was the middle managers were not trained or were not skilled to handle these models. And they were so busy in their day-to-day. I mean, they said like, okay, if the CEO has said something, I'll take care of it. Like it has to go through me, right? So how do we make them the part of the solution? It applies to both AI as well as all the sustainability solutions. And this is, in our view, one of the biggest roadblocks in adopting AI and sustainability solutions within Fortune 1000, the Fortune 5000 companies. So I know we have talked a lot about opportunities about AI, and I want to go into the risk side as well. And the reason I want to go into the risk side, because yesterday I was watching the World Economic Forum videos of the CEOs from the 90s, right? Because I like history. I like from my Edison example, you can tell that. I like combining both the future trends with what we did in history. In all of those videos, CEOs, and this was the time, I'm talking about 90s, when the internet boom was taking place. And after that, there was a software boom, right? All the CEOs at the Davos stage in forum were talking about how technology will lead to a better society, more equality, and this is quote unquote, the exact statement, will lead to reduction in price of commodities. 30 years from then, where are we? We can debate about this, whether software trends or internet trends have been net positive for the world or not. But what I do know from my own personal experience, the price of essential food commodities have gone up 4x. Healthcare, education has become more and more unaffordable. Forget developing countries, even in the States, the single biggest cause of bankruptcies in the United States is healthcare-related bankruptcies, right? We are at the cusp of another wave, which is the AI wave. So we should not repeat the same mistakes as we did 30 years ago, right? But humans are very good at repeating those mistakes. So let me pose this question to the panelists here, all the way from from the startup, and then we'll go to the corporate side. And any of you can jump in. What are the risks that you see in deploying AI for sustainability solutions? And in fact, some of the opportunities you talked about, can you play a devil's advocate for your own solutions, right? If you were pitching to a venture capitalist, right, and how would a venture capitalist push back? What would those reasons be?
Let's see here. Tough question. I mean, I think one of the things we've really learned over the last year has been, I think, even our approach to what can AI do now? How can we integrate it into our business? And then what is really the ultimate potential for AI? And so I think the founding premise of Orbital was that if you could create a foundational model similar to what an AlphaFold was for DeepMind around how you can predict protein structure, you could basically have it pop out miracle materials, new battery materials, new carbon capture materials, and those are ultimately the solutions you're going to get. I think what we really discovered is that so much of the data, so much of the model, so much about the implementability of it, that it really is actually a great opportunity for chemists like myself. Like I'm not a machine learning researcher, I'm a chemist, to come in and actually really direct the way in which these models are actually developed to really help create, I think, actionable ideas for us to move on over the next few years. And the way I see this technology evolving is that in many ways what we're doing will probably be a more expensive way of developing our first product because so much time and effort is being spent building machine learning and AI into it from the very beginning. But I think ultimately my belief is that as we build up the data, as we build up the in-laboratory expertise, as we actually prove that the AI is giving us valid results experimentally, then that's where the ability for, I think, us to ultimately make profound and unexpected discoveries, powered primarily by the better insights come. As a chemist, I have the ability to really think through, I think, the structure-function relationships of a material. But as we move to new and emerging and promising classes, some of those are just harder for, I think, us to really understand what those relationships is. And I think super-powered foundational models will really allow us to unlock a lot of really new things and ultimately be able to iterate faster. So I think we were talking about this a little bit earlier ago. Cobalt, nickel, manganese, many of the things that go into lithium-ion batteries are becoming rarer, more and more dilute. We spend more energy getting that. The faster we have the ability to ultimately iterate and make variations and improvements on those materials and do so less expensively will be, I think, be really critical in making sure that we're not over-leveraged in a single technology. Because I think the mistake is if we go all in on one thing, then I think that's where a lot of the unintended consequences come from.
What do you think, Remco? What are the unintended consequences?
Yeah, I think a very obvious one here is that we have to avoid that all these models that we develop in order to save the world are having more negative impact because of their consumption. And I think just to put some numbers in context there, I don't want to be pessimistic, but I want to lay out the numbers to kind of get an order of magnitude. Like I mentioned, all data centers combined, 300 terawatt hours comparable to the UK. The water consumption right now, I'm not sure if any of you came by train, you see this frozen lake on the way here, Lake Davos. Hundreds of billions of liters of water per year is about every 2 weeks you deplete the entire lake over there just to cool down all those data centers. That's a lot. So that's a lot right now. But if you look at, there was some post, I think, couple of months back where somebody analyzed if we replace all Google searches with ChatGPT, how much power is that going to take? And their numbers were around, I think, 30 terawatt hours annually, which is comparable to, I believe, around Ireland. So as if we put another Ireland on the map. Now, bear in mind that these are extrapolations of today's technology with an exponential growth, and of course, take them with a grain of salt. But the numbers you can really look at is, for example, the sales of NVIDIA GPUs. I think by the end of next year, or by the end of this year, they'll have sold around 3.5 million chips that if you put them all on at the same time, at the same power, at full power, you talk about a consumption of, again, around 40 terawatt hours of power, which is, I think, around Denmark. So you put a Denmark on the map. So you really talk about the scale of countries when you talk about the levels of electricity consumption that we're consuming here. And I think the pitfall we need to avoid is that what often happens is we install a lot of energy-consuming installations, and then we try to figure out how do we reduce the losses of what we install. And if we can do it right from the beginning, I mean, a data center today is basically an electric hairdryer. You have electricity that comes in, and you have hot air that comes out. But I think it's better if we start looking at data centers and anything we use for AI more like a power plant, where we look at how much energy is to be put in and what do we get out to, for example, residential heating, using waste heat for carbon capture. A lot of exciting opportunities that work really well if we design systems from the ground up to be more like a power plant and less like an electric hairdryer. And I think there's huge opportunities there to make sure we don't have to fix the problem, but we do it right from the start.
Great. I know we are running out of time, so I want to leave 10 minutes for audience Q&As. But before first question will be for you, sir. But before we do that, let me just wrap this up, and I will request the panelists to go back to the tweet mode, right? So we have heard from the startup entrepreneurs. Let's hear from the corporates, including WWF. You work with a lot of corporate partners. I said you work with a lot of corporate partners, right?
Are you in trouble?
Please do not blacklist us. We will still love to work with you. So we have seen a lot of sustainability reports, right? We have seen now a lot of AI roadmaps coming out of the desk of the CEOs and the CIOs or CTOs from Fortune 1000 companies. What I do see in those roadmaps is the opportunity part, the impact it could create for those Fortune 1000 companies and how it could create another $100 billion, $500 billion, and so on and so forth. What I don't see is the risk part, right? So what would it take for both of you to say like, hey, for any roadmap that you publish, let's factor in the risk part as well. And then, of course, we'll go to you, Thomas, about how can you work with corporates on that.
So I'm blessed that I work in a company that has to do with risk, but also embraces data and technology. And we're probably leading in our industry in doing so. talking about the risk, yeah. So there are areas that we don't know yet about, yeah. So that's the unknown. But what we need is everything around AI needs to follow a proper data foundation and data strategy in organizations to embrace this and to make this part of your DNA. So it takes time, it's a journey, but it has to happen. Otherwise, you will have a proliferation of use cases, individual use cases, and add complexity to already a complex environment in companies. So that's the one thing that I would say. Have a proper governance around all your AI use cases. In my business unit alone, we've got 40 use cases, solid governance around it, because there is risk. Now, I'll open one, and that's for the future, but that's something I want to plant the seed. On the liability side, more and more shifts to software, to data, etc., algorithms. Take automotives. Today, it's the motor insurance. In future, it will be a corporate insurance, a liability on software. So there will be a new discipline that will appear because there's increased risk. One of the risks is software malfunction. Nobody talks about it. How do you quantify the exposure of software malfunction? You don't have data yet to model. We're already struggling with cyber as an exposure. So I just urge everyone, when you see the opportunity, be disciplined. When you even study software engineering, etc., there's some housekeeping things and hygiene things that we need to introduce into this discipline. Software malfunction, algorithms, bias in data, and not only in data, but also then in the algorithms. This is the next big thing, and I don't want this to become the next asbestos, because this will backfire on us all, on the industry, because insurance companies won't be able to insure it. That will increase the protection gap, and our purpose is to reduce protection gaps and not to increase it. So that's my plea.
Isa?
Yeah, look, I mean, the governance piece is super critical. I won't repeat what you said, right? It's one of the things that we are also now helping our customers try and deal with is this question of what data is going in, where's that data going, how do you trust what's coming out, right? Because we haven't talked about that on a global scale. You've got questions around biases and whether they're relevant for all parts of the world. You've got new questions around if the next frontier is GPU processing power, how do we make sure we don't lose part of the world, right? So I think those are bigger questions, right? But from a corporate, how do we talk to our customers? It's governance for our own, but also to help our customers deal with that.
Thanks, Isa. Thomas, in tweet style.
Tough one. No, I think really important stuff's been mentioned. It's the quality of the data. I mean, we did an analysis where we found that companies were claiming that they were, carbon neutral based on algorithms that were based on satellite data that just wasn't what was happening on the ground. You need drones, you need people actually measuring on the ground, you need to combine it. So there's the thing about quality of data and external verification of the data, I think, as well. We've heard the handprint versus footprint. I think that's something also as a corporate you always need to think about. How much more good are we doing and what's it going to cost us? And maybe just a final one, which is a bit out there, which is if I follow a lot of the discussion around AI, it just strikes me how it always references human intelligence as a benchmark. Think about there's other intelligence out there as well. We've had a couple of millions of years of evolution. So go out there and actually look at some of the intelligence that's out there in other species and think about how that can inform your conversations about AI. That is really lacking. And we see that in biology as well, where we've made all these assumptions that we are the only ones that have intelligence. Actually, it turns out that we've made such dumb experiments. We've designed them in a way that the only thing we test for is human intelligence. And all of a sudden, we realize there's a lot more out there. And when you start opening that up and talking about AI as a multitude of different intelligences out there, it just gets so much more exciting.
I agree. So we just have 5 minutes left. So we have time for 2 questions. talking about human intelligence. And whoever asks the hardest questions from the panelists will get the light bulb. All right. Yes, sir. And please, may I also request you to sort of limit your question to a tweet question, right? Rather than a LinkedIn post question. Okay.
A hard tweet question.
My name is Johannes Kimberger from the OECD AI Policy Observatory. Another question on a risk that I think hasn't been mentioned, because there's always a dichotomy between AI taking a lot of energy, water on running it, and then beneficial applications. What about the harmful applications like AI for oil and gas exploration, AI that is being used in social media to spread climate misinformation, AI for accelerating unsustainable consumption patterns, kind of second, third order effects, not just unintentional, but intentional applications that run counter to climate goals?
Thoughts? Unintentional or intentional effects of our consumption patterns?
I would say that's exactly why governance is important. So we have a steering body where all use cases go through, and they're being stress tested against all our rules that we have in place. So that will be eliminated then.
And again, compare footprint and handprint. And if your handprint already is negative, then you're really in for a problem.
Yes, and before I go to you, I also want to thank amazing questions sent to us by the students from University of ETH. And the reason I like questions from the students are they are unfiltered, right? They don't care about their jobs. They don't care about the media headlines. They truly care about what they believe in, right? So we'll go to one of those questions, but yes, sir. Why don't you go for it?
What is intelligence?
How many hours do we have for this one?
I think like
No, I think it's adapting yourself to succeed in your environment. And you know, you've got species out there which are incredibly specialized on a specific niche, and they've been around for millions of years. Now, there is inherent intelligence in that. So I don't think it's about, am I able to solve, you know, a really difficult equation, but am I able to adapt and thrive within a certain environment, which also means that the species around me will thrive in that environment. And I think that's where maybe we should have a bit of a question mark about our own intelligence. Maybe it's not quite what we always thought it was. But you know, if you design an aeroplane, you know, maybe it's a good idea to look at how birds fly. I mean, that's why, you know, if you want to go back in history, that's where a lot of the inspirations come from, right? So we go to nature to be inspired. And I think we get surprised every time we realize what's out there. And I'm just thinking, you know, combining that knowledge out there, and not just individual knowledge. Like if you take an ant or a termite, on its own, it you know, has a certain amount of intelligence, but put it in a colony, and it starts building the most amazing artifices, which you know, so there's collective intelligence out there as well. And I think by opening up our understanding of what intelligence means, we end up with much more exciting solutions.
Great. I think we all got a primer on intelligence. So, how are we doing on time, Jennifer? Okay. So we have time for one more question, but I would prefer it to come. I mean, we can do two questions from amazing women in the audience. Anyone with a great question? We'll come back to you, sir. Yes, please.
It's a bit specific, but I was wondering, scope 3 was mentioned earlier, and that it's a challenge and that we need to track the data, and it's important so we don't blame others for the footprint. Why is it still so difficult to set goals when we say that it's important to have the goals? Just pointing at you, Isa, I know that Swisscom doesn't have those goals currently.
Oh, we do. We do. We have an SBTi target to be net zero, including scope 3 by 2035. It's still challenging because not all our suppliers track their data in a way that we'd like them to track it, right? So, but that shouldn't make it impossible. It's just a journey. But we do, yes.
Great.
And I think a lot of those scope 3 targeting of your suppliers is oftentimes based upon estimates. And if you actually go in and do real measurements of the CO2 emissions of like a furnace, they can be very different from what the estimate is. So it's actually hard to get really good data on some of those as well.
Yes, sir. The last question belongs to you. And the floor is yours. Remember, everyone will remember you in this panel because you are the last person standing. They won't remember us, what we said. They will remember you. So with that in mind, no pressure. Go for your question.
Okay, so I'm Kai from Berlin. I'm advising family offices for their impact investment strategies. And my question is to Andreas and to Thomas. You mentioned data. Yeah, we need data for measuring the impact for biodiversity. And you mentioned we need to verify the data, what the company, and you said companies can put their own data on your platform. So my question is, can AI help? Do you see any signs to verify these data and to get rid of data mining and things like that?
First of all, in investment institution family offices are actually one of the most interested one in our solution. Why? Because they exactly look at their portfolio companies and they want to do exactly what I just described. Build a digital twin. It's not about your data. Your data is your data. You bring it on the platform. But then when we do CAD modeling, then we need to rely on official data as input. And that's where the quality of data kicks in. It needs to be objective. When we do parametric trigger-based solutions rather than indemnified solutions, we need to have an objective trigger, because otherwise it doesn't work. So there's a clear, robust governance around this. Otherwise it wouldn't work. Yeah, so I mean, I could go now into much more detail, but yeah, we can follow up.
10 seconds, and then we'll be kicked out of the panel. So,
So external targets like science-based targets, we're now developing something similar together with companies for biodiversity, that we can do the same thing. And that has the advantage, you don't just set a 2050 target, but you have a path, and you regularly report on where you are there. And AI can help in the way I described that tool we developed for the regulators and the investors, to analyze a transition plan to see whether it's credible or whether it's a lot of that hot air coming out of the hairdryer.
Yeah. So with this, I'll leave all of you with one thought, right, which came up in the panel discussion as well, which is our consumption trends, right? We can talk about any solutions. We can blame corporates. We can look at entrepreneurs as heroes or whatnot, but we ourselves have to be the real heroes. As an example, and I did this research yesterday because I have to be in a panel tomorrow with will.i.am, and there'll be a lot of school students there, and I'm very scared. For 100 GB of photos that you store in your cloud, if you are an American resident, your emission footprint would be 0.2 tons, which is more than what an average Tanzanian citizen or an average citizen from Burkina Faso ends up emitting for their entire year, for all the activities, right? So really think about, do we really need to buy 6 clothes every month, or every season, or every holiday season? Do we really need to click so many pictures, right? So why end up creating a problem and then look for, blame corporates or look for corporates for solutions? With that, let's give everyone a round of applause. And as I promised, this light bulb goes to you, sir.
Hey, surprise.
Throw it. Oh,
No. That won't be a great light bulb moment.